I am Dr. R. Srinivasan from Freshman Engineering, IARE, Department of Chemistry. So we will see in this video electrochemistry problems. In that electrochemistry problems, we will see half cell electrode potential and cell EMF E0 cell using Nernst Equation. So we will see this problems using Nernst Equation. So it comes in module 1, electrochemistry, module 1, half cell electrode potential and cell EMF using Nernst equation. So obviously half cell electrode reactions, we will calculate half cell potential, electrode potential using Nernst equation. For voltaic cell, full cell reaction or electrochemical cell reaction, we will calculate cell EMF using Nernst equation. Okay. So this is the course outcome. Module 1, utilize electrochemical cell parameters under given condition for calculating the EMF and electrode potential. Apply is the Bloom's taxonomy. Okay. So we have already seen in the last video EMF or electrochemical series and its applications. Okay. Or EMF series. Okay. So these are all the from increasing order. From minus 3.4 it increases. Okay. And then it reaches 0 and then again it decreases. Okay. It increases, increases. Plus 0.34 to plus 0.8 to 1.3 to 2.8. It increases, increasing order of electrode potential, standard electrode potentials. Next, this we have to find the electrode potential, means obviously electrode potential of the following half cells at 298 Kelvin. First one, ferrous sulfate 0.1 molar bar Fe. Standard potential is minus 0.44. So according to the reaction given for this half cell, this is the half cell reaction. This is the half cell reaction. This is reduction. Okay. The E0 cell is given as minus 0.44. So according to Nernst equation, for reduction half cell, reaction, E cell, EMF of the cell is equal to E0 cell plus 0.0591 by N logarithmic concentration of metal ions. Okay. Concentration of metal ions. You can write it 0.0591 by N logarithmic concentration of M. Okay. Similarly, here EMF of the and this is not E cell. This is E cell, E0 cell will come only for cell reaction. This is half cell reaction. So this is electrode potential. This is half cell electrode potential and E0 is standard electrode potential, reduction potential, which is given in the EMF series. So E cell, E0 cell will come only in the Nernst equation if we discuss about the cell reaction, like Daniel cell reaction between zinc 2 plus copper gives copper, zinc plus copper 2 plus gives zinc, copper 2 plus zinc 2 plus copper. If you have a cell where anode, cathode both are involved, then E cell, E naught cell. Here only half cell, reduction half cell. So it's electrode potential at standard electrode potential. Standard electrode potential, this is not E naught cell, this is E naught. Standard potential. So number of electrons involved is 2. Okay. Concentration is 0.1. So this is the, actually 0.1 means 10 power minus 1 minus 1. So this minus becomes minus 0.0591 by 2. So this is the answer. Okay. Similarly, second part, platinum, hydrogen 2 atmosphere by HCl, 0.02 atmosphere. So this is the reaction, half cell reaction. Half cell reaction. This is in again 0 plus 1. This is oxidation. Okay. This is oxidation. Also, this is reduction. So here E is equal to E naught minus 0.0591 by N logarithmic. Okay, you can take it concentration of product by concentration of reactant. Okay. Now we know this is hydrogen cell. For hydrogen cell, E naught is 0. For hydrogen cell, standard hydrogen electrode or hydrogen electrode, E is taken as E naught is 0. Okay. So 0 minus 0.95, 1 electron is involved by 1 logarithmic concentration of H plus product by reactant, pressure of hydrogen. For gases, pressure is the concentration. So pressure of hydrogen power 1 by half. So if you substitute, we get the answer. E is equal to 0.109 volts. This is the answer. Okay. So if you substitute log of 0.02 by 2 power half is root 2. So if you substitute, you will get answer E is equal to 0.109 volts. This minus into minus will become plus. Okay. Plus 0.109 volts. This is the answer. Next. Calculate the electrode potential of copper wire dipped in 0.1 molar copper sulfate solution at 25 degree centigrade. Standard electrode potential of copper is 0.34 volts. So again, Nernst equation is E copper is equal to E naught copper plus 0.0591 by N logarithmic concentration of copper 2 plus ions. Okay. Yeah. So E is equal to 0.34 plus 0.0591 by 2 logarithmic log of 0.1. Okay. So which is changed to minus 0.03. So this is the answer. So answer is this. Next. Calculate the electrode potential of a zinc electrode dipped in a solution of 0.05 molar zinc sulfate in which the degree of dissociation is 0.6 at 298 Kelvin. Standard electrode potential of zinc electrode is minus 0.76. Degree of dissociation. For example, zinc gives Zn plus 2 plus 2 electron. Okay. This is oxidation. Okay. This is one side. But what we want to see here is electrolyte. For example, strong electrolyte like KOH or HCl. These will be having 100% dissociation. Okay, they will become 100% ions immediately. Very fast, immediately. Okay, whereas point alpha is equal to degree of dissociation, which is equal to 0.6, means only 60% becomes ions. Okay, that means here the concentration 0.05 molar given, we should take into 60 by 100, which is equal to 0.03. This is the concentration of zinc 2 plus we have to take, because that only we have to take 0.03 molar as zinc 2 plus concentration, because 0.6 means 60% only degree of dissociation. Okay, so this is the Nernst Equation formula. This is E naught minus 0.76, N is equal to 2, concentration is 0.03, not 0.05. Okay, 0.03, because 60% alpha degree of dissociation. So this is the answer if you calculate. Okay, now we comes to Nernst equation for a EMF of a cell. We have seen so far single electrode. For single electrode half cell reaction, let's see, Nernst equation is E is equal to E naught plus 0.0591 by N logarithmic concentration of product by concentration of reactant. Or we have seen directly E is equal to E naught plus 0.0591 by N logarithmic concentration of metal N plus ions minus. Okay, this becomes plus here. So this is the formula we used for potential, electrode potential. E is electrode potential, E naught is standard electrode potential, N is number of electron transfer, this is concentration of ions. Now comes to EMF of a cell. E is equal to E naught minus, E cell, EMF of the cell is equal to standard EMF of the cell minus 0.05 mm by N logarithmic concentration of product by concentration of reactants. So if you take example Daniel cell, what is the cell reaction? Zinc plus copper 2 plus gives zinc 2 plus plus copper. Now this is the Daniel cell reaction. Now for this Nernst equation is EMF of the cell is equal to 1.05 1 volt is the Daniell cell EMF minus 0.0591 by N logarithmic concentration of zinc 2 plus divided by copper 2 plus. So this is standard EMF of the cell. Now this concentration may change, temperature may change. So this Nernst equation is used for calculating the EMF, electrode potential or EMF of a cell for non-standard conditions or any given conditions. Okay. Next, the standard reduction potentials of zinc and copper electrodes are given. What is the EMF of the cell? So this is here. If you see, the concentration varies. Okay. Okay. So how to find the E naught of the here? E naught we want E naught of the cell is equal to here again. This is a Daniell cell type with concentration varies. So 0.34 minus of minus 0.76, which is equal to 1.1 volts Daniell cell. This is the thing here. Now, if you apply the Nernst equation, E cell is equal to E naught cell minus 0.591 N log concentration. So this is 1.1. This is 2. N is equal to 2. 2 electron transfers. So N is equal to 2. And concentration of zinc is 0.05. Copper is 0.05. So it will log 10. Log 10 is nothing but 1. So divided by 2 into 1. So this is E cell is equal to 1.07 volts. So this is how we have calculated using the EMF of a cell given using Nernst equation. Next, lead 2 plus cadmium solid gives lead solid plus cadmium 2 plus. Here, so E cell is equal to EMF of this cell given cell reaction, given cell is equal to E naught cell minus 0.0591 by N is equal to 2 logarithmic concentration of cadmium 2 plus divided by lead 2 plus. So we know that concentration of metal is equal to 1. So we will take it as unity and we won't take that into the, it's more or less same whether you take it or not, it's 1. Okay. So whether you substitute multiply by 1 or not, it is same. So concentration of metal we considered as unity 1. So EMF of the cell is equal to E naught cell is 0.277 minus 0.5, that is 0.0295 logarithmic 0.02 divided by 0.2. So again this becomes 0.77 minus 0.0295 into 1 because this is 10. Okay, this becomes 10. Oh, sorry. Log. Okay. This is log 0.02 into 100 is equal to 2. 0.2 into 100 is equal to 20. So 1 by 10. So this becomes log 1 by 10. So becomes plus here. Plus log 10 1. So which is equal to EMF of the cell is equal to 0.29. 0.277 plus 0.0255 16. 0.3, so 6 by 3065 volts. This is the EMF of the given cell. So this becomes 1 log of 1 by 10. So this is minus, becomes 10 power minus 1. So plus log 10, it will become plus. How this came? Because this is log 10. 1 by 10, we term it as 10 power minus 1. So minus 1 log 10. So plus log 10. Okay, next. Calculate the EMF of a cadmium copper cell in which cadmium is in contact with 0.02 molar cadmium sulfate and copper in 0.02 molar copper sulfate. The standard EMF of the cell is 0.74. Okay. Okay. So this is clear. E naught cell, E cell is equal to E naught cell minus 0.51 by N logarithmic concentration of product by reactants. So E naught cell is 0.74. This is 0.005. 0.002 by 0.02 is 0.1. That is plus, it will become plus, similar to the last problem. So this is the answer. 0.74 plus 0.0296 is equal to 0.7696 volts. Okay. Next. For the cell Fe solid or Fe2 plus 0.01 molar salt bridge, Ag plus 0.1 Ag solid, write the cell reaction and calculate the, here directly calculate the EMF. Here cell reaction is there. Write the cell reaction and EMF of the cell at 298 Kelvin if standard potentials of iron and Ag are given. Okay. Okay, cell reaction now. For that cell representation, we will make it first. Cell representation is given directly. What is given in the cell representation? Oxidation iron. Okay, reduction is so anode half cell reaction, which is oxidation. Cathode half cell reaction, which is reduction of cell reaction. Anode Fe gives Fe2 plus 2 electrons. Cathode. Okay. 2 Ag plus 2 electron gives 2 Ag. 2 Ag plus 2 electron gives 2 Ag, reduction. Okay. So now standard EMF of the cell is equal to reduction 0.80 minus of minus 0.44. So which is equal to 1.24 volts, that is given here. Okay. That is written here. So now E cell is equal to 1.24 logarithmic iron 0.01 by point. Okay. So here Ag plus square, because 2 is there. So this 2 will go as a power here when it comes to concentration. Log of 0.01 by 0.1 square. So this, both the terms are equal. Log 1, which is 0. So this term will become completely 0. So E cell, directly standard E cell is equal to EMF of the cell at this condition given. 1.24 volts is the answer. Okay. Whether you do by E naught cell or by substituting the concentration, both are coming equal in this problem. Okay. Next. Write the overall cell reaction for zinc solid bar Zn2 plus ions at 0.2 molar. Okay, this two separation salt bridge Ag plus 0.002 molar by Ag solid, and calculate the EMF of the cell at 25 degrees. Standard is 1.54. Okay. So here also EMF cell representation is given. So cell reaction. Okay. 1 minute. Overall cell reaction here is, you will write here. Overall cell reaction is Fe plus 2Ag plus gives Fe2 plus 2Ag. This is the overall cell reaction here. Now here cell reaction anode of cell or oxidation of cell, anode or oxidation of cell reaction, cathode or reduction of cell reaction. So here zinc gives zinc 2 plus 2 electron. This is anodic oxidation. Cathodic reduction, again 2 Ag plus 2 electron gives 2 Ag. This is cathodic reduction. Now overall cell reaction is zinc plus 2 Ag plus gives Zn 2 plus 2 Ag. Okay, this is the overall cell reaction. So 1.54, how it comes? E0 cell is equal, standard EMF of the cell is equal to reduction of cell 0.80 minus of minus 0.74. So which is equal to 1.54 volts. Actually it is 76. We can take it as 1.56 also. Okay. So, but given is 1.54, so we have taken at 1.54. Okay, no problem. So EMF of the cell is equal to standard EMF of the cell minus 0. This is the Nernst equation. Concentration of product zinc plus 2 divided by reactant Ag plus square. This 2 will go here. This is 2. This 2 Ag, 2 moles of Ag. This Ag, when writing concentration, goes as a power. Okay. So 2 electrons are involved. So N is equal to 2 in this reaction. Concentration of zinc plus is given. Concentration of Ag plus is also given. So if you take 0.002 whole square, 4 into 10 power minus 6, if you do calculation, 0.0295, and the logarithmic of this value, logarithmic, we will get 0.14. So answer is 1.4 volts. EMF of the cell here is 4 volts. 1.4 volts. EMF of the given cell, answer is 1.4 volts. Okay. So reference books are Jain and Jain, Engineering Chemistry, Shashi Chawla, textbook of Engineering Chemistry, R.V. Gadak and Nityananda Shetty, Engineering Chemistry book. Okay. So this video is over. We will further continue seeing the other things from the next video. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.